Half day students, welcome to day one of your online classes here at FD. I'm here at FD, you're at home, lucky you. Okay, Guahusi Miss Pangilinan. So we're going to start with today's lesson of exponential growth functions, where we're going to start seeing the application of exponential equations. Okay, so a quantity is growing exponentially if it increases by the same percent in each unit of time. This is called exponential growth. So we're going to look at some of the examples of linear growth versus exponential growth. Linear growth is when it increases by a certain amount every time. If you see an increase in tuition, increase by $500 every year, can also work with deduction. So we're going to see a negative increase, so a decrease of $100 monthly in a certain thing. Exponential growth is where it actually relies on what the original amount or cost is. So tuition increases by 10% every year. So it's multiplied by the same number every year. Car decreased by 20% annually. The amount of toilet paper, people need triples every day. So it also works for like a double, triple, half, things like that. So where you're not multiplying or adding a certain number, you're instead multiplying by something to get a new number. Okay, so we're going to look at growth rates and growth factors. First of all, we're going to look at the percent. Tuition increases by 10% every year. So obviously this is a positive. This is 10% increase. To find the growth rate, we're actually going to find the numerical equivalent to the percent, which basically we just take the percent and divide it by 100. 10 divided by 100 is 0.1. 0.10, whichever works for you. Growth factor, since I'm actually adding this, we're adding it to 100%. So I'm going to do 1 plus 0.1, which turns out to 1.1. So that's what you would multiply it by. So the value of the car decreases by 20% annually. Now it's going to be a negative 20%, a decrease, right? The growth rate would instead become the same thing, so we find the numerical equivalent, which is going to be 0.2, but now we're interpreting as a negative. The growth factor, if it's decreased by 20%, I'm actually going to do the existing 1 minus 0.2, which is going to become 0.8. And we're going to be using these for our models in the next few problems. The amount of toilet paper people need triples every day. So if I see this, it's tripling every day, you're multiplying it by 3, right? But I want to see what is the percent increase when I multiply something by 3. That just means it's a 200% increase because it's going to 100 to 300%. So I'm increasing by 200%, which is basically a growth rate of 2. The growth factor would be 1 plus 2, which is 3. So you're just multiplying it by 3. Exponential growth model. This is a basic formula that we use for many of the growth models. When something is increased or decreased by a certain rate over time, this is what we would use. Where C would be the initial amount. R is going to be our growth rate. And this 1 plus R is actually our growth factor that we talked about, where you just add or subtract. Obviously, if R was a deduction, then it would be just a negative R. And T is actually going to be the time period. So just pay attention to whether it's in days, hours, months, years. It works for either of them, but they just have to be in the same one, or whatever the question's asking, whatever your answer is going to be. Okay. Yes, so we're going to be using this for our next few problems. Example 1, finding the balance in an account. You deposit $500 in an account that pays 8% annual interest, which is actually really good. Compounded yearly. What is the account balance after 6 years? Okay, so method one. So if I didn't want to use my exponential growth rate model, basically what I'm just doing is I'm saying, okay, my percent rate is 8%. I know this is the equivalent to 0.08 if I was to find the numerical equivalent, 0.08. So basically what I'm doing, if I'm finding how much is each year, it's just basically, okay, so after 1 year, it would be $500 times 1.08, right? 100% of it is plus 8%. That would be 1 year. After 2 years, it would be 500 times 1.08 times 1.08, whatever that amount was, times 1.08. The following year would be the same thing again, 1.08 times, you guessed it, 1.08. You'll notice that this starts to form a pattern. After 6 years, it would just be 500 times 1.08 raised to multiplied to itself 6 times, which is the same as 5 times 1.08 raised to 6. So you'll notice in the next method, so you could find it this way, but it may take long if you have a larger number for your t. This one's only 6, so it can be done. But it introduces us to using our formula, which is to do this. So we're going to use our formula where y is equal to c, our initial amount, times 1 plus our rate, our growth rate, raised to t, which is our time period. Okay. So c is going to be 500, is going to be obviously our initial amount. 8% is our percent growth. So our r is going to be r here is going to be 0.08, right? So we have 8 divided by 100 equals 0.08. So we have r equals 0.08. C is equal to 500. I'm going to set this up. And this is going to be 6 years is t, right? So I'm using this formula. Y is equal to 500 times 1 plus 0.08 raised to 6. Okay. If I was to apply this, when you do this in your calculator, you're going to do whatever's inside the parentheses first. Please remember PEMDAS. You do whatever's inside the parentheses first. So y is equal to 500 times 1.08 raised to 6. Do the exponent next, parentheses exponent. 1.08 raised to 6 in your calculator. You'll be doing that, and then multiply it by 500. So this actually becomes about $793 or 793.437. So we're working with money, so when we answer our question, so the amount of money left in the account would be using this dollar sign, $793. And of course, I'm going to round it to how many cents they are unless otherwise specified, and 44 cents. And that is our complete answer for this one. Moving on to example 2. Writing an exponential growth model, we're still doing more of these. A town with a population of 5,000 grows 3% per year. Write an exponential growth model of its population and estimate the population at the end of 10 years. So I already know, I can already identify my C, my initial amount. 10 years is going to be my T. 3% is not my R, but I'm going to use it to find my R. So finding R. Okay, so I'm going to do 3% divided by 100 is going to give me 0.03. If you notice, I just moved the decimal point 2 times to the left. 0.03 is my growth rate, so that is my R. So I'm going to set up my equation. Now I'm using P for population. The population is equal to my initial 5,000 times 1. It grows by 3%, so I'm adding this population growth. I have this rate of 0.03. We're adding it and then raising it to t. Our time is 10. The base one would be actually raised to t. Let's go make this actually a general formula. Raised to t. So it'll work for any year. Okay. If I want to find it specifically for 10 years, obviously I'm just going to plug in 10 for t. P is equal to 5,000, 1.03 raised to 10. I already did the addition. 1.03 raised to 10. You would do that first. And then you would multiply it to get approximately 6,719.582. Okay, obviously, if I'm looking at population of a town, I'm not going to say, oh, they had 6,719.6 people. So we're actually going to round it to the nearest whole number. I'll say, okay, they're going to have approximately 6,720 people. Looking at the last problem. Write an exponential growth model. A population of 20 rabbits is released into a wildlife region. The population triples each year for 5 years. So looking at this again, if it triples, what is the percent increase? It actually increases by 200%. Because if it goes from 1 to 300%, 100% to 300%, that's an increase of 200. What is the population after 5 years? So look at this. We're going to set up an equation or a model again to find this. So we say, okay, our population P is going to be equal to our initial. 20 rabbits is our initial. That's the C that we're using. 5 I'm going to use for the T. Yeah, it triples. So we have the 200%. So 20 times 1 plus 2, because we're looking at 200%, right? So our growth factor, it becomes 1 plus 2, right? Which is 3. Raised to t. So this is the same as 20 times 3 raised to t. If I want to find the population after 5 years, 20 times 3 raised to time of 5 years, which becomes 4,860. Okay, and then we always interpret our answer for word problems. The population of rabbits is after 5 years will be 4,860. Okay. I'll be sending you some handouts to work on. Don't forget to give this video a thumbs up and subscribe.